Hi students, so welcome. So today we are going to cover this topic moment of inertia. What is moment of inertia and how do we practically calculate it? What is the unit? What type of quantity it is? Okay, so let's start it. Okay, so let's first understand what is the moment of inertia. So before going on the moment of inertia, let's talk a bit about the mass and inertia. Mass and inertia. So before coming on this topic, you must have studied about the Newton's laws. So Newton's laws say that if a object, first Newton law says that if a object is there and there is net resultant a force on a object is zero, then the object will try to maintain its state of motion, and this is also known as law of inertia. Okay, so uh, inertia, what is mean by inertia is that any object tries to maintain its tries to maintain its state of motion, right? Okay, state of motion. Like for example, if you are having a car and that is moving, okay, and if you want to stop it, so you will apply a brake, right? Either car will be continuing to move. Of course, it will after some time it will stop because of friction, right? Because net resultant force on a car is not zero. Like this, if a car is there and that is stationary like this. Okay, this is the car, our car. Okay, fine. Okay, it may be not be looking like car, but still you can assume. Okay, so it's our car. If it is stationary, so then it will be stationary, right? And if you want to give it a velocity, then you need to apply some external force. Okay, so there is a resistance to change its state of motion. Resistance, and that resistance was, we can say it is a kind of inertia, like we also have the inertia. Like you want to when you want to wake up in morning, so there is also some kind of inertia to continue the sleep, right? Okay, so some kind of that in the object is there, that is the inertia. Now how do we practically calculate it? How much the inertia? That is given by the mass. So mass is measurement of inertia. So mass is the measurement of inertia for the translation motion. Okay. Translation motion means when object is moving and all the particles in the object are moving the same distance. So then that motion is known as translation motion. So the inertia for the translation motion is measured as mass. Now, if we take another object, okay, let's say this is our rigid body, because moment of inertia is connected to rigid body. That's why I am taking here the example of rigid body. So let's say this is our rigid body, okay, and this is the axis of rotation. It means that we are going to rotate this object about this axis. Fine, you want to rotate. So let's say initially it was not having any rotational motion. Omega was zero. Now, if you want to give some omega, then you need to apply some external torque, or here you just can take it as force. You need to apply some kind of force on it to give some omega, some angular velocity to it, right? So here this object is also having the inertia for to maintain its state of rotational motion. Okay. So here we can say, or we can define the moment of inertia, that uh, inertia or the resistance of an object to maintain, okay, to maintain, let's keep it like that, to maintain its state of rotational motion. And that is the moment of inertia. Okay. Now we are getting what is moment of inertia. Like for example, fan is there, and now you want to rotate the fan. You want to have that fan should be having some, let's say, 10 radian per second velocity, angular velocity. Now for that, you need to give some torque to that fan. So that there is a resistance to maintain its state of motion, that is moment of inertia. Okay, now then how it is defined. Okay, so moment of inertia is defined for a point mass. It is defined as I is equals to mr square, where m is mass of object or mass of point mass, r is the perpendicular distance from axis of rotation. Okay, fine. So here it is for the point mass. For example, let's say this is our axis, and okay, and this is the point mass that is kept over here. Now mass is 5 kg, let's say, and this is, let's say, 2 meter. So what is the moment of inertia for this object? That will be m into r square. That will be, I will be 5 into 4. That will be 20 kilogram meter square. Okay, so it is defined like this for the point mass. Okay, then how it is defined for a system of particles? Okay, so next thing we are gonna discuss uh, moment of inertia for system of particles. Okay, for example, let's take it. Let's say this is a axis of rotation. Okay, okay, fine. Let me erase it. Okay, so yeah, fine. Let's say this is axis of rotation, and there are multiple masses that are kept. Let's say there are mass, this is mass m1, this is mass m2, and so on up to mass n, that is having a distance rn from the axis of rotation, and mass mn. Okay, and this is having a distance r1 from the axis of rotation, this is having r2, like this. Okay, we want to find out a moment of inertia for the system of particles. So that will be, because moment of inertia is a scalar quantity. Okay, so we can just add the numerical value, and that will be the total value of the moment of inertia. So what we can do, we can calculate the moment of inertia for individual particles like I1, I2, I3, I4 up to In, and we can just add up it. Okay. So when we say I system will be equal to sum of m1 r1 square plus m2 r2 square plus so on up to mn Rn square. Perfect. Okay. So now we can just write it down like this. This is summation of I is equals to 1 to n mi square. Right. That is for the where the particles are there and these particles are point masses. Okay. There are n number of particles and which are point masses and this is defined like this. Okay. Now let's go on the uh, next thing. Moment of inertia for continuous body. Okay, if you want to find out for continuous bodies, moment of inertia, then what we can do? Let's say, for example, I am taking this is our continuous body, this is a rigid body, and I want to find out moment of inertia about this axis of rotation. Okay, so what I do, I take a element, and this is a infinitesimal element, and so that's why the I can consider it as point mass. Okay, so the I can define the moment of inertia for this element, that will be elemental mass multiplied by the distance square. And now I can add up for the other elements as well. Okay, so because here this elemental uh, moment of inertia is continuous, that's why we can just integrate it. So total moment of inertia for the rigid body is integration of di, and that is integration of dmr square. dmr square. So that is the moment of inertia for the continuous body. Okay, so uh, we have learned in this lecture what is the moment of inertia, what is the practically meaning of it, how do we can understand it, and then how we can calculate the moment of inertia for individual point mass, and then we can how we can calculate the moment of inertia for the system of particle, how we can calculate moment of inertia for the continuous body. What is the unit for moment of inertia? It is kilogram meter square. What will be the dimension? Dimension will be ml2, and is it a vector or scalar? It is scalar. If you want to take it, you can also take it as tensor quantity. Why? Because in different direction moment of inertia is different. Okay, right. So that's all for today, and in the next lecture we are going to study about the next how we can calculate. We will take the example. So if you want to understand, you can just click on the next lecture. Okay, thank you.